The definition of something being a factor is that the remainder is 0. Yesterday we talked about how to find the remainder using the remainder theorem. If your remainder is 0, that means that that is a factor. So let's go back. If you divide 3 into 15, it would go in there 5 times. You have a remainder of 0. And what that tells me is that 3 was a factor of 15. Conversely, if you take 3 into 16, it will still go in there 5 times, but now your remainder is 1. And that's because 3 is not a factor of 16. So what we're trying to see is x minus 1 a factor of this function? And we're going to use the remainder theorem. The first thing you want to do is set this factor equal to 0. And what do you get when you set this equal to 0? X minus 1 equals 0, you get 1. So you need to find f of 1. Find f of 1 to see if you get 0. If you get 0, the answer is yes. X minus 1 is a factor. For part B, you're going to find f of 2 to see if you get 0. So in the homework, because now we're doing homework 15 questions, which the due date for that is now Friday, but I might move that back. But just always check Canvas. Check Canvas all the time, see if things change. So in that question, when you see these questions in homework 15, this is how you're going to test if it is a factor. You're going to test to see if it's a factor based off of the remainder. If the remainder is 0, it is a factor. So now we're going to take that 1 and substitute it in. So that would be 4 times 1 cubed minus 2 times 1 squared plus 1 minus 3. Type that in your calculator. I have a calculator here too if somebody needs one. And there's also a basket by the clock of extra calculators if you don't see any around you. That one doesn't work. The one on your desk doesn't work. So late. She didn't so bad. It's okay. I was just asking because sometimes they stop working. So that's why I was like, maybe it doesn't work. I had to throw away a couple yesterday because they stopped working. So go ahead and do parts A and B. And see what you get. So what did you get for part A? What is f of 1? Who got 0? So that would mean that this is a yes. Yes, x minus 1 is a factor. If you get a remainder of 0, that means that it is a factor. What did you get for part B?
-4.
So what would that mean? No. This is not a factor. And the next thing we're going to do is find factors. So now we're testing a factor to see if it is a factor of a function. But now, tomorrow, we're going to actually start finding the factors.
Okay, so can you explain again why 0 is yes and -4 is no?
So if you divide 3 into 15, you would get 5 with a remainder of 0. That means that 3 is a factor. If your remainder is 0, you get 0 as a remainder when that number is a factor.
So we're looking for the remainder. Like we're not like.
We're trying to verify that it's a factor by finding the remainder.
So it's not like we're getting an answer.
No, we're just verifying it.
Okay.
Yeah. All right, so the next thing we're going to talk about is Descartes' rule of sign. I'm not sure if you should copy down. Well, yeah, go ahead and copy it down, and we'll talk about it. I'm sorry? Are we going to graph it? What graph?
The chart.
The chart. Oh, yeah. Yeah, you can. So we're doing example 4 and 5, and then we'll be done. So we have it all copied down?
Yes.
Okay, so now what we're going to start doing in this last part before we take our next quiz is you will be given a function, and you're going to have to tell me all of the zeros and factors of that function. So one thing that some people find helpful is figuring out how many positive real numbers or positive real solutions, how many negative real solution, how many imaginary, and how many in total you're going to have. The first thing I want to say is that the total number of solutions you're going to have will always match your degree. And the degree of this function is what? 7. So that means that this function has 7 solutions. Okay. So first, let's figure out how many of those solutions are positive. And it's really simple. All you're going to do is count your sign changes. So what I start off with is a positive 3. So I'm going from a positive to a negative. Did I change signs? So I'm going to put a 1. Then I go from negative to positive. Did I change signs? Yep. Positive to a positive. Did I change? Positive to a negative. Did I change?
Yeah.
Negative to a negative. Did I change? All right. So how many sign changes did I have? 3. So I'm going to put a 3. Now, the one thing that you want to keep clear is that in this column, this tells you this is the highest number. This is the most I can have. I can't have more than 3 positive real solutions. But you can also count backwards by 2. So you can also, for these 2, we can count backwards by 2 from my starting point. So if I take 3 and take away 2, how many would I have? What's 3 minus 2? 1. So that means that in this first column, the only numbers that I can use are 3 and 1. If I try to go backwards from 1 2 times, I have a negative, and that's not possible. So the only 2 numbers, so we can only count backwards by 2. We can only count back by 2. So we have either 3 positive real solutions or we have 1 positive real solution. So now let's see how many negatives we have. Yes. You can only count back by 2. So you start off by figuring out how many sign changes you have, which we have 3. And now we can only go backwards by 2. That's like the math thing. Descartes. He figured it out. He was a genius. Way smarter than me, I'm not gonna lie.
He's a Greek.
Yeah. All right, so now let's figure out how many negatives. So what I'm going to do is highlight all of my terms that have an odd exponent. These 3 terms have an odd exponent. And I'm going to rewrite this function, and change the sign of those 3 terms. So let's write f of negative x. F of negative x is going to be, so instead of a positive 3x to the 7, I'm going to write negative 3x to the 7. The next term does not change. Instead of a positive 3x cubed, I have a negative 3x cubed. Am I going to change the next term? Nope. Instead of a negative x, I have a positive x. All right, and I want you to do that again. I want you to count your sign changes. So negative to a negative, that was no change. A negative to a negative is no change. A negative to a positive, that was a change. So the reason why we flip that is because if you put a negative in for x, it's going to change that positive 3 to a negative 3. because -1 to an odd power changes the sign. -1 to an even power would stay the same. So then I went from a negative, so sorry, I lost my train of thought. Positive to a positive, so that would be no change. And positive to a negative, that would be 1 change. So altogether, how many sign changes do I have? 2. Put a 2 here. And remember, we can only count backwards by 2. So if I take 2 minus 2, I get what? 0. So this column can either have 2 or 0, and this column can only have 3 and 1.
Where did the 1 come from again?
Counting backwards by 2.
It's always 2.
It's always 2. So now we need to figure out what number goes here. The number that goes here, now first of all, has to be even. And I need to figure out what number I need to put in this column in order for this row to equal 7. So right now I have 3 positive, 2 negative. Remember, I need to have 7 altogether. So 3 plus 2 is 5. So what number do I need to put here? A 2. So if you add these 3 numbers, do you get 7? 3 plus 2 plus 2 is 7. All right. What number do I need to put here? Oh, sorry. Let me put my 7 right here. What number needs to go there? 6. Is 1 plus 0 plus 6 equal to 7? All right. So now, what if we have 3 positive? We already figured out if we had 3 positive and no negative. Remember, I could also have 2 negative. So what if I put a 2 here? No, sorry. What if I put a 0 here? Because we already figured out the 3-2 combination. What would be my 3-0 combination? Because you need to fill out all of your possible combinations. So 3 and 0. Remember, this has to be a 7.
4.
So how many imaginary would I have to have? 4. Does anybody want to take a guess what I'm putting in that last row? 1, yep. And a 2. Because we haven't put those together yet. And if I have a 1 and a 2, how many would I have to have imaginary? 4. There's 2 questions like this in your homework where you have to make a chart. All right, let's do one more and then we'll end there. This one is a 4th degree, so it should go a lot faster. All right, go ahead and copy that down.
Yeah. Yes, it's breakfast. It's breakfast. It doesn't say anything. Nope, I didn't. I just.
Wait, hold that thought, because we don't have a lot of time. Okay. So my degree is 4. So that's the only number that can go in that column. So let's count our sign changes for positive. So positive to a positive, I did not change. Positive to a negative, did I change? Negative to a negative. Negative to a negative. All right, so how many positive real solutions will I have? Can't have a such thing as a negative. So just 1. If I try to go backwards by 2, I'm negative. So that means that the only number that I can put in this column is 1. Can't have anything but 1 in this column. If you go backwards by 2, now we have negative, and that's not possible. Okay, so there's 1 positive solution. So now let's find our negative solutions. So I'm only highlighting my odd functions because I'm actually substituting in a negative x. But if I put in a negative x to an even degree, it's not going to flip the sign. If you put a negative x into an odd degree, it will. So this first one is going to say x to the 4th. This becomes negative. This one stays negative. This one flips to a positive. So let's count our sign changes again. So this will be a 1. There is no change. This has a change. And this has a change. Let me make sure I didn't. Okay. So negative to a positive, positive to a negative, 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 positive. Okay. So how many negative real roots can I have? 3. Now I can go backwards by 2. If I go backwards by 2, what would I have? 3 minus 2 is 1. So let's go ahead and fill in this row here. So we know this one has to say 1, and this number has to be a 4. What number am I putting here in order for this top row to equal 4? 0. What about my second row? 2. Does everyone understand why there is no need for the last 2 rows? Because I can only have 1 here. So there isn't any other possible combination that I can create. So there's only 2 possibilities, two rows.
So where are you counting them to? Like what are you counting?
I'm counting backwards by 2 to get other possible, to find out how many real roots I can have. So this tells me the maximum.
Oh, so you just take that number and go back by 2.
Yes.
Okay.
Mm-hmm.